Hi guys, welcome back to the vlogs.
Okay, independent events and multiplication rule. An independent event is an event in which the outcome on one has no effect on the probability of another occurring. So they're separate from each other, okay? The fact, let's talk about this. Something that's not independent would be like this. We might not have a track meet today if it keeps raining. So if the rain happens, the more likely of the rain, the more likely track will not happen. Does that make sense? Whereas, you could say, if it's thunderstorming outside, the basketball game is still on. Those two things are separate from each other. The higher percent for rain doesn't affect you having a basketball game. Okay? So independent events are when events, one does not affect the other from happening, or the probability of another occurring. Multiplication rule is the probability that both events occur equals the product of the probabilities of the two events. Okay? The probability that both events occurred equals the product of the probabilities of the two events. So if I take event 1 and it is a 0.25% chance of happening, 25% chance, 1/4, and the probability of another happening is 1/4 also. When you multiply those together, that would be the probability that both events occur. And I'm going to flip it to the next one because it has the multiplication rule on there. Okay, and independent stuff, so that's why. Formula for the multiplication rule is the probability A and B of event A and event B. Probability of A times the probability of B divided by A. Okay? If events A and B are independent, then the probability of B of A equals the probability of B. And the multiplication rule simplifies to simply this. Probability of A times the probability of B. This is the simplest form of the multiplication rule. Probability of A times the probability of B. Okay, one can recognize if two events are independent using this rule. For instance, let's say the probability of rain is 0.3 and carrying an umbrella is 0.1. If the probability of both is 0.05, the events are not independent. If they were, the product would be 0.3 times 0.1, which is 0.03. Okay, so they have to come out to equal those. On the other hand, let's assume the probability of taking a green marble from a bag is 0.4. And the probability of drawing a diamond card is 0.25. If the probability of doing both is 0.1, the events are independent. Since 0.4 times 0.25 is 0.1, these two events occurring together would be considered independently combined probabilities.
So wait, if the two things equal what the probability is, then it's independent, and if it doesn't, then it's dependent?
Correct.
I know, I had to dump down my hair.
If they're equal, they're independent. If it comes out to not equal that, then it's dependent. Okay. What is the probability of a coin coming up heads twice? How can I figure that out?
So you're flipping it twice.
Well, you have two chances.
Yeah,
Okay, so you have, what would that represent fraction-wise?
0.5. Well, 1/2.
1/2. So, if I flip a coin once, I have a 50% chance, correct?
That's what I was thinking, like.
When you flip a coin again, you still have a 50% chance. So you take 1/2 times 1/2. What do you get when you take 1/2 times 1/2?
1.
Yeah, 1/4. So the probability of flipping a coin and having heads twice is 25% chance.
She said 1.
You said 1.
Now, next one. A bag contains 11 marbles, where 3 are red, 2 are green, 6 are blue. You choose a marble from the bag. You replace it, then you draw again. What's the probability of drawing a red marble followed by a green marble?
So, hold on, you have 11.
You have 11, good.
Okay.
So you
three
turn
are
over
red.
11.
So probability of A would be what?
11.
11.
no, something over.
Yeah.
So, wouldn't it be
3?
3?
Okay. What's the probability of B?
2 over 11, and then 6 over 11.
No.
No.
You do 3 11s times
Oh, to
2
get
11s,
oh,
and you get 6 over what?
121.
121. A little bit different. Okay. So you have a 6 over 121 chance of pulling out a red marble followed by a green marble when you replace the marbles.
Yeah, I saw that.
Okay.
Did you see? Even she doesn't like them.
There is a 30% chance that Julie will work on Saturday and a 70% chance of rain.
What does rain have to do with? Sorry.
There is a 50% chance her favorite hockey team will win that evening.
These events.
If the events are independent, what's the probability that on Saturday Julie works in the rain and her hockey team wins?
So wait, would it be out of 100, or would it be out of all those added together?
That's a good question.
It would be
Thank
all
you.
of them added together.
Not added.
Wait, no.
Multiply.
So you're multiplying
together.
all of the
30,
percentages
70.
together. So instead of putting it in percent form, what form am I going to put it in? Decimal. So what's probability of A in decimal form?
0.3.
0.3. What's probability of B in decimal form?
0.7.
And C.
0.5. I got that right.
So then I just am multiplying 0.3, 0.7, and 0.5 together, correct?
Mm-hmm.
So what is 0.3 times 0.7 times 0.5? You get what?
105.
0.105. Change that to a percentage now, because you got to change it back. 10.5.
Got him. That wasn't me.
So you have a 10.5% chance of it raining, her working, and her team winning.
That wasn't me.
That's what it's looking for. Does that make sense? Okay.
Kayla, are you sure it's not 105%?
Wait, there was one more. What's the probability that you draw 2 queens in a row from a deck of cards? You do not replace the cards that you draw.
Okay, so
How many cards are there in a deck?
52.
52.
It'd be out of 50 though.
And how many queens? No, how many queens are there?
4.
4.
4.
So what's
No,
probability of
actually
A?
4 over 52.
4 over 52. What's the probability of B?
Wouldn't it be 2 out of 50?
Wait.
No, it,
8. 3 out of 51. Because if you
Because you
pull
have to
out a
move
queen
one.
and you don't replace it, you're down to 51 cards now, and you're only down to 3 queens.
okay.
Okay? So now I take these 2 events, and what do I do with them?
Multiply.
them.
Okay, so we know 3 times 4. What's 51 times 52?
2, 6, 52.
No, it's
26, 52.
221.
52. No, I
52 times 51?
Oh, wait, no.
No, it's 52 times 51 is 221.
No. 50.
It don't work.
2 times
Wait.
51.
Wait.
Are you adding? I think you're adding them.
no, I know what I'm doing. It's
Wait.
what? What'd you say?
26, 52.
2,652. Reduce this.
Divided by 12.
1 over 221.
There you go.
Okay, always reduce.
Whoa.
Okay, 2 more slides. They're all examples. They're just word stuff. Okay, compound event. A compound event, okay? We're going to kind of talk about that a little bit too. A compound event, okay, is kind of like this. I'm going to give you an example. I'm going to read an example out loud so you can understand what it's like. Let's say that you want to calculate the probability that if you draw 5 cards, one after the other, at least one of them will be both a club and a numbered club, such as 3 of clubs. We assume each time you draw a card, you return it to the deck. In other words, the probability that if you draw 5 cards with replacement, you will get the 2 of clubs, the 3 of clubs, the 4 of clubs, or any other card that is both a numbered card and a club. This is called a compound event. Okay? Club and number card. When it asks for 2 specific things for 1 card, that's a compound event because 2 things are happening at once. dog can be white, black, or chocolate colored. 25% of the breed will be chocolate colored, and that is the color we want. What is the probability that if we visit a breeder who has a litter of 6 puppies, we will find, I should say find, a puppy that is chocolate colored that we will take home and love?
Aww.
No. How do I figure that out?
I want a chocolate puppy. Those things are cute, bro.
I know they are cute. How do you figure that out?
Like a chocolate lab. Those are so cute.
Faith.
Sorry, I'm
Faith focus. How do you think we figure that out?
Okay, there's a 25% chance the breed will be colored.
a compound event.
I'm not
Copy.
Right.
So you have a breed of dog. What are the options for the colors they can be? White, black, or chocolate. And they said that 25% of a breed comes out chocolate, correct? Okay. So we have white, black, chocolate. We know that this represents 25% of a breed. How much is in this breed right now?
6.
6 puppies. What would be 25% of 6?
If there is a
1.5.
What did you say?
1.5.
1.5?
You've been saying 1.5.
25 over 100, and then it's over 6.
Right?
So 1.5 dogs come out as, right, basically. So,
Quick
how do I
math.
figure that out then? What do I have to do? We will find a puppy that is chocolate colored.
Do you
You
put
go
it
one-
next to a chocolate?
1.5 of the dogs come out that way, which means what do I do with that?
You put it into
You
a
put it
percentage?
over,
Over what?
6.
Over 6, and what do you get? Oh, that should be 25%.
Yeah.
That's not right. 1.25. Wait, what? 1.25, right, it's 25%. So breed of dog, 25% of the breed will be chocolate colored, and that is the color we want. What's the probability that if we visit a breeder who has a litter of 6 puppies, we'll find a puppy that is chocolate colored that we can take home and love? Okay. Would it be what?
Don't bring one
Yeah, it
and
don't
have
make sense
puppies
because you
all.
can't have half of those.
Yes. Chocolate's good.
Do we round? Let's just say $2 or chocolate.
Let's
Then
just
we have a
round up
50%
and say
chance.
$2.
Right, let's just round up and say
Okay.
2 dogs.
Okay, so a chocolate puppy in the litter would be 4 of the 5 times there were 1 or more chocolate colored puppies, right? Again,
I want a chow chow puppy.
Okay,
Those
you're
things
done,
are
you're
done.
cute.
We don't care about you and your love for puppy. Actually, we do.
we have
But
thank you. They have to be
Those things are
missing.
dang cute though.
Oh, I know what we would do. Okay. So we are missing something. You have to actually make your own example here. Let's do this.
Huh?
25% of a litter comes out chocolate most of the time, yes? So we need to, remember how yesterday we said, hey, let's let cards represent this, or let's let whatever.
chicken
We have to do
nuggets.
the same scenario, okay? If you take a deck of cards, how many suits are there?
A 10-piece chicken nugget.
How many suits are in a deck of cards?
What's a suit?
A suit would be hearts or
Oh,
4.
Good,
Four.
Kate.
That's what I said.
I can't hear you. Okay, so there are 4 suits in a deck of cards. So let's
I'm a
say
mayor.
okay,
You
let's
obey my
say-
orders.
that you do this, experimental wise. 2, 4, 6, okay? You have 6 puppies, correct?
yes.
Okay, and let's say we just use the higher cards. You have a jack, a king, a queen, and ace, right?
Mhm.
Jack, king, queen, ace. So if I take that, and there's 3 breeds, correct?
Yes.
Okay. So if I would take that and figure out the probability, if you use cards as a simulation system, we use 4 cards, the jack, queen, king, and ace of spades. With the ace representing the 25% probability of a chocolate colored puppy, okay? Draw the card with replacement once and a card next, so you're gonna set up like a, example of what that would look like. So if I have a king, a queen, a jack,
Why do you have two queens?
4, 5, 6, okay? Because we figured out that 25% of 6 is about 1.5, so we round down to 1 puppy. I can't round up to a second puppy.
Because biology don't work like that, Kayla.
Okay, so we represent this, and we just keep drawing and representing this a few times, okay?
It can be.
Let's say in the next one, you have a jack, a king, a queen, a jack, a queen, and an ace. Okay? You have an ace, a jack, a king, a queen, a jack, and a king. Okay? So you would do this like 6 times. You would just do it to experiment with it and see what the probability is of you pulling that out. And you would write down those results and then figure out what the probability of you getting that puppy is. That's how they want you to do experimental probability with it.
So basically,
You have to set up your own test group.
Can't you just go to the store?
Like, you know, in science when you set up your own test stuff and you just like pull from it. And do
yeah. So
stuff.
basically, you're doing your own thing
Experiment.
based off of that
Yes.
problem.
Yeah.
Why couldn't they just make our life easier? Just say, hey, you can just do this to solve that.
Well, okay,
Yeah,
try this
it's
last
bad.
one, and then I'll give you
Mental
homework.
abuse to humans.
Okay? What is the probability of drawing at least one card that is both a club and a number card if you draw 5 cards?
Ooh, combination. Oh.
What is the probability of drawing at least one card that is both a club and a number card if you draw 5 cards? First of all, how many clubs are there in a deck? There are 4 suits. How many cards are in a deck of cards?
52.
52. So take 52 divided by 4. You get.
No one likes the jokers. Jokers are just
You guys focus. 13. Okay. How many of those are numbered cards? Out of 13. You have an ace, a king, a queen, and a jack that are not numbered, right? Ace, king, queen, jack that are not numbered. So how many number cards do you have? 9. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you have 9. Okay, so you want it to be both a club and a numbered card. Okay, how many clubs did you say we had? 13 out of 52. That's probability A, yes? Probability B would be what?
9.
9 out of, 13. 9 out of 13. So what do I do with those two things?
multiply them
Multiply them together. What's 13 over 52 times 9 over 13? What's 13 times 9?
13 times 9 is
117.
117.
What's 52 times 13?
676.
676. Are either of those reducible?
No.
What do they come out to decimal wise? Go ahead and do it decimal wise.
Divide them together.
0.173.
Oh, should I?
So you have a 17.3% chance of pulling out a numbered card that is also a club. Okay? That's the type of stuff we're working on, Kayla.
Or career or faith, I don't really care.
Like, subscribe, comment, tweet me at David Dobrik. Anything else to add, faith or
Kill
career.
me.
Oh my gosh.